Okay, in this video we're going to look at planes in 3 space. So planes in 3 dimensions. So planes, think of them like this. They are infinite parallelograms. And they expand infinitely all from all 4 sides. So something like that. So think of them like, I like to think of them as like big sheets of ice. And they are all over the place and they intersect. They intersect at points, they intersect at lines. So basically planes are what make up your 3 dimensions. And likewise with lines, planes can be written in equation form. So we're going to look at how to write the vector and parametric equations of a plane. So it's very similar to a line. So let me write it out here. So the big difference between a plane and a line, and we got S and T are real numbers, is that you have 2 direction vectors. So again, your R naught would stand for a point on the line, your A vector and your B vector, and you could use different variables, would be 2 direction vectors. So very similar to a line. So we're going to look at when you are given 3 points on the plane. So I'm just going to scroll that down. So how to create that equation of a plane, you're given 3 points that lie on the plane. So if we're looking at this plane here that I drew, something like this, right? 3 points on the plane, and you're going to be able to create a vector and parametric equations for them. So let's just write that out again. Okay, so let's look at 3 points. I'm going to give you 3 points here. I'm going to give you A, -1, 3, 8, B, -1, 1, 0, and C, 4, 1, 1. So you're going to need 2 direction vectors from this, and you can choose any 2 combinations that you want. So I'm going to go for AB, and I'm going to go for BC, and we are going to do the change in X, Y, and Z like we've seen in previous videos. So you can look back to refresh your memory on that. So vector AB would be 0, -2, -8, and BC would be 5, 0, 1. Sorry about that. So once you got your vectors, you're pretty much done. So again, R naught, you're going to choose one of the points. So you can choose any one of these points. So I'm going to choose the A point. And then I've got plus S, and then my first direction vector. And then plus T, my second direction vector. Now again, you can have infinitely many different looks to this, because your vectors, you choose any parallel vector to that one and any parallel vector to that one, you're correct. You can choose any point on the plane. I just happen to choose that first one. So just like the line, you're going to have to get used to it. There's infinitely many different ways that you can look at the equation of a plane. And same thing for parametric, you're just going to break apart the components. So x is -1, so you're going to expand here by s, so no s value, plus 5t. Y is 3, so this would be -2s, no t value. And then z is going to be 8, -8s, plus t. No symmetric in planes, you're just going to go with vector and parametric. So another situation would be if you know a point on the line, point on the plane, and a line on the plane. So let's look at what that might look like. So here is a plane. So again, think of a plane as this big sheet of ice in the form of a parallelogram that expands all 4 directions infinitely. So in this situation, you know a point, and then you also know the equation of a line. So I'm going to give you a point. Here's an example here. We're going to go 1, -5, 9. And then I'm going to give you the line. I'm going to give you the vector form of the line. So again, for the plane, we're going to need that point. So we got a point. Actually, we got 2 points. I'm going to show that in a minute. And you need 2 direction vectors. And of course, S and T are any real number to take into account the parallel vectors that you have going on. So again, for R naught, I could choose this point. It's on the plane. But because this line is on the plane, that means that point is on the line, which means it's also on the plane. If I wanted to, I could choose that one. I'm going to choose the first one. Okay, now you need 2 vectors. Well, this line is on the plane. So that means this direction vector that is parallel to the line would also be parallel to the plane. So you can use that one. So I'm just going to put that in. You could put that in for A or B, up to you. So you need another vector. So that's where these 2 points come into play. So I'm just going to go over here. And I'm going to generate a vector based on those 2 points, which now we know lie on the plane. So I'm going to do the changes in all the components. So I'm going to get 1 minus 1, then I'm going to get 1 minus minus 5, which is 6, and then 1 minus 9, which is minus 8. So I could use this vector right here. But again, if you wanted to, like you could take a look at that and say, oh, I can factor out a 2. Oops, forgot that 0 component there. Sorry about that. So this is only if you wanted to. Like, it's not necessary to do this because that vector there, 0, 6, negative 8, is perfectly fine. But this is also fine too. And you need to be aware of those situations or else you're never going to get used to, internalize the concept of parallel vectors. So again, you could have that. If you didn't want to factor that, that's fine too. You could have just used 0, 6, negative 8. But again, infinitely many possibilities. So that is how you generate the vector and parametric equations of a plane in